When you're adding or subtracting fractions, it's important to remember that you need to find a common denominator. And to do that, you want to first factor the denominators that you start with. So in the case of our first problem here, negative 2 over p plus 1, you can't factor the bottom part. So I'll put parentheses around it to remind myself I'm treating it as a group. But when we look at the next one, 4p over p squared minus 1, you can factor the bottom of the second one. That's a difference of squares. And we would have p plus 1 times p minus 1. Now, to get a common denominator, you want to think when you're looking at each fraction, is there anything on the bottom of the other one that's not on the bottom of this fraction? For example, when I'm looking at my first fraction here, it's missing the p minus 1 from the bottom of the other fraction. So to get my common denominator for this one, I have to multiply the top and the bottom part by p minus 1. Now the second fraction, there's nothing that it's missing. There's a p plus 1 on the bottom of the first fraction, but there's already a p plus 1 on the bottom of the second fraction. So that one, I don't have to multiply by anything. It's not missing anything. So when I get my common denominators here, my common denominator for the bottom is p minus 1 times p plus 1. That's going to be my denominator for both fractions. On the left side, when I distribute p minus 1 times negative 2, p times negative 2 is negative 2p. Negative 1 times negative 2 is a plus 2, like that. And then we have 4p from the top of the next one. So now, when I'm adding fractions that have common denominators, I just add the top parts, just the way they are. Negative 2p plus 2 plus 4p. The bottom part stays the same, and we combine the like terms from the top. Negative 2p plus 4p, we would have 2p plus 2. Now you factor the top part. On the top part, you can factor out a 2 from both of those terms. You would have 2 times p plus 1. On the bottom of the fraction, we have p minus 1 times p plus 1. So to finish it, we can see that there's a p plus 1 on the top and the bottom part. They cancel each other out. So the final answer on this problem is 2 over p minus 1. These adding problems do have a lot of steps, so be careful as you're going through. Let's look at another adding problem. So again, before you start thinking about getting common denominators, you need to factor the denominators you're starting with. On the bottom of the first one here, to multiply to be a positive 4 but add up to a negative 5, you would need a minus 4 and a minus 1. So we have k minus 4 times k minus 1. That's our bottom part of the first one. For the second one, that's a difference of squares. It would be k minus 1 times k plus 1. So that's our denominator for the second one. So now when you're trying to figure out what do I need to multiply by each fraction to get common denominators? For the first one, you're thinking, what is the bottom of the first one missing that is on the bottom of the second one? And that would be k plus 1. It doesn't have that. So I'm going to multiply k plus 1 by the top and bottom of that first one. For the second one, when I think about what it's missing that's on the bottom of the first one, that would be k minus 4. So I'm going to multiply k minus 4 by the top and bottom of the second fraction. So looking at this, I'm going to go ahead and just put the bottom part of my answer, which is going to be k plus 1 times k minus 4 times k minus 1. And from that first fraction, forgot to put the 1 there. I need to do k plus 1 times 2k. K times 2k is 2k squared. 1 times 2k, I just have plus 2k. I'm going to save a step by going ahead and putting it as one fraction. So for the next one, 3 times k is 3k. 3 times minus 4 is minus 12. Now combining the like terms on top, we have 2k squared plus 5k minus 12. On the bottom, we still have the same thing, k plus 1 times k minus 4 times k minus 1, like that. All right, oh boy, now we need to see if we can factor that top part there, 2k squared plus 5k minus 12. Let's see. It looks like you can. It looks like if you factor that one, you're going to have one group with a 2k, another group with a k, and then let's see, you would have a minus 3 here and a plus 4 there. Yep, that works. And on the bottom part, you have k plus 1 times k minus 4 times k minus 1. Now there's nothing here that's exactly the same. There's a k plus 4 on top, a k minus 4 on the bottom, but you can't cancel out part of a group, and those groups are different. So that would be it. That's your final answer from that problem. So you get your common denominators, combine the like terms on the top, factor the top part, and then if there's a common factor, you reduce it. If, like this case, there's not a common factor, you have to leave it alone. That's it. So let's look at one more adding problem. Here we have m over 2m minus 3n plus n over 3n minus 2m. Okay. Here the trick is noticing that the bottom parts at first look very different, but they're actually almost the same. Those are those subtraction opposites that we talked about. Now, when you have that, if we want to get these to be common denominators, you can leave that first fraction alone and what you do when you want to switch around the order of one of those subtraction opposites like that, you put a negative in front of the top part of that fraction. By switching the order here of the 3n and minus 2m, I'm taking the opposite of that. So if I'm doing the opposite of the bottom of that fraction, I need to do the opposite of the top of that fraction as well. And now those fractions already do have a common denominator of 2m minus 3n. And for the top part, I just combine those. M plus negative n is the same thing as m minus n. So the point of this example is to show you just a time-saving trick. Instead of multiplying by a whole bunch of stuff, I can get a common denominator here just by switching the order on the bottom of the second one. If you switch the order on the bottom, you put a negative sign in front of the top.